Hello, and welcome back to the Carbon Capture Magazine podcast. I'm your host, Danielle Piekarski, and support for today's episode comes from Vaisala. Vaisala is a global leader in measurement instruments and intelligence for climate action, offering unique measurement solutions for carbon capture, utilization, and storage. With almost 90 years of innovation and expertise, Vaisala's experts are dedicated to equipping customers with highly accurate, low-maintenance CO2 and humidity measurement solutions that enhance process efficiency, control, and transparency. Their flagship CO2 instruments include the MGP 241, GMP 343, and GMP 250 series, which are designed for precise, continuous CO2 monitoring in both direct air capture and point source capture applications. These robust inline and ambient sensors are seamlessly integrated into existing systems, providing significant operational cost advantages and regulatory compliance support. At Vaisala, they are committed to taking every measure for the planet, and I am joined today by two guests dedicated to that mission. We have Justin Walsh, who works in business development at Vaisala, and Antti, Heikkilä, product line manager at Vaisala. Welcome to the podcast.
Thank you very much.
Thank you.
Of course. So to start, can you talk about what you two see as the most significant trends shaping CCUS and how Vaisala is positioned to participate and contribute to this industry as CCUS evolves in the global effort to achieve net zero and net negative emissions?
I would say that the most significant trend is that we are moving from pilot and proof of concept demonstrations into full-scale carbon capture projects. And when that transition happens, the role of the off-taker becomes more important. We are now at the stage where several players in the industry can technically capture carbon dioxide, but when you do that on a full scale instead of just a small demonstration project, there needs to be an industrial off-taker for that carbon dioxide. So I would say that a big trend is CCU, using the carbon dioxide, whether it is for converting that to methane and then to other fuels or converting it into methanol, and from there to a wide variety of green chemicals.
Yes, and from the United States perspective, we are seeing a lot of direct air capture technology development. So there are a lot of startups, to Antti's point, progressing into more demonstration projects. From the point source side of things, there's been a lot of progress with solid sorbents in membranes. And we have equipment to support all of those operations from benchtop instruments to a full-scale industrial level.
And I would also like to add that besides measuring carbon dioxide in the capture process, we can then support customers with measuring CO2 purity in the captured gas when it's transported as gas or converted into a dense phase, or if carbon dioxide is then utilized in, say, methanation, we can then also offer solutions for measuring methane together with carbon dioxide.
Great. Okay. Well, thank you both for giving us that knowledge to get started. What are some of the key challenges that your customers are facing in the CCUS industry, and how do Vaisala's products address these challenges?
I would say that the biggest challenge currently is how to reduce the OPEX cost of producing a ton of carbon dioxide. So the processes need to be run more efficiently, and process optimization with real-time online gas measurement is what we are offering. Typically, especially if one uses liquid solvents, which are still the most common solvent technology, so that might be a simple water wash system, amines, or hot potassium carbonate, or other salt-based systems. These involve a lot of heat exchangers, heating and cooling the solvent, and pumping the solvent from one place to another. And this is very energy intensive. And the energy cost of capturing carbon dioxide is currently somewhat too high. And this needs to be optimized, and that's something where the measurements can help. So we can detect unideal situations in the process, such as the solvent being too cool and not capturing carbon dioxide, and then carbon dioxide is going back into the stack or it's released into the air. And we can help customers avoid that with timely measurements typically in the incoming gas stream, then the captured product gas stream, and in the lean gas that is sent typically back into the stack, or in the case of direct air capture, vented directly into the atmosphere.
Yeah, and more from just a basic measurement perspective, a lot of the smaller companies and technologies that are at a lower technology readiness level, they're using instruments built for different industries, whether it be a little bit more of a oil and gas or as different as, say, fermentation type of instruments. So stability and repeatability, a lot of attention needs to be taken to calibrate these instruments. Very involved sampling systems are constructed in order to use less than ideal measurement instruments. And so we have purpose-built products that are much more stable, robust, and lower maintenance to reduce the OpEx and avoid kind of shoehorning something into a process that it was not necessarily designed for.
Yep. One of the challenges that people doing direct air capture or these smaller modular solid sorbent or membrane type point source systems is that they are building systems that in an ideal situation would run unmanned, remotely controlled 24/7. And most of the product offering available for measuring CO2 online comes from chemical industry process analyzers or continuous emissions monitoring systems for power plants. And these systems, together with conditioning and sample transport lines, probes, pumps, etc., they need constant maintenance. There needs to be an instrument technician checking those, if not on a daily, then at least on a weekly basis. And that doesn't gel with the concept of most of the new types of carbon capture plants that we see emerging. So having a simple transmitter that is no more maintenance intensive than, say, a flow meter or a pressure transmitter, but measures carbon dioxide accurately is clearly what the industry needs.
Earlier in the introduction, we had mentioned Vaisala's flagship CO2 instruments, including the MGP 241 and GMP 343. We touched on the uniqueness of these probes. What makes them different, and then where do they fit into both direct air capture and point source capture systems?
What makes them different and unique is Vaisala's patented CarboCap technology. So our instruments are based on an improved non-dispersive infrared NDIR technology. The CarboCap technology that we use enables us to eliminate the drift almost completely from the measurement, and it renders the instruments also insensitive to cross interference from other gases. These miniaturized sensors, which we make in our own clean room in our Helsinki, Finland factory, also have an excellent lifetime. Typically, they are built for over 10 years of continuous use. So in these instruments, there are no moving parts inside. There are no consumables apart from a simple particle filter that the user can replace if necessary. And they are very small in size, typically fitting in a 1.5-inch process fitting, consuming only a couple of watts of electricity. So we are replacing a 6-foot tall cabinet that needs to be moved in with a forklift and needs 3-phase power with a small, less than a foot long, 2 inches in diameter transmitter that runs on 24-volt power and needs minimal maintenance.
Yes, and for perspective on the direct air and point source capture systems, the 343 is the highest accuracy, low-level CO2 probe on the market. And specifically for direct air capture systems, you're able to very accurately monitor the ambient conditions coming in, and then the clean airstream, the lean CO2 airstream that goes back into the atmosphere. Now that delta tends to be, only a couple hundred or a little bit more parts per million. And so having a 3 ppm accuracy there really allows the end user to track how well things are going and detect breakthrough from their sorbent media. Comparative things on the market are in the 10s, 20, 30, 50, 100 ppm accuracy range. For the 241, that's our full range system. So that supports both direct air and point source capture systems by quantifying the purity of the CO2 that's been captured.
And one thing that is unique about the 241 is that most instruments have an accuracy that decreases when the measuring range increases. So they are most accurate close to zero, and the closer you get to the full 100% CO2, the accuracy starts to trail off. We designed our instrument from the beginning to be able to accurately monitor in that 90 to 100% range for purity analysis of the captured CO2 stream. So the accuracy actually improves the closer you get to 100%, which is very different from most instruments available. A typical process control instrument has a 2% of range accuracy, and we offer 1, so that's twice as accurate as most competitors.
Mm-hmm. And uniquely, the MGP 241 also measures the water vapor content in parts per million or dew point temperature, which no other CO2 probe is really doing or capable of doing. And that comes into play a little bit more with the direct air capture systems that might be doing a temperature vacuum swing absorption. And a lot of water vapor is released with the captured CO2 stream. So we can measure both, and we can account for the cross sensitivities in those measurements.
Yeah. It is actually also useful for point source when you are measuring the lean stream that goes back into the stack and is released into the air. Because when CO2 is measured for emission reporting or environmental compliance purposes, you are typically recording or reporting it on dry basis, which requires knowing the water content or drying the gas before measurement. And we solve this by measuring water vapor together with CO2. So you get both wet basis and dry basis output directly from these instruments, which is something that you normally only have in a big multi-gas continuous emissions monitoring system.
Okay, very interesting. Thank you. I recently read about a case study that you've published with Capsule Technologies. Could you share some of the insights or results that were covered in that case study about the pilot?
Sure. Full case study is available at Vaisala's website. And Capsule, a Norwegian company developing hot potassium carbonate-based point source carbon capture, approached us, and together we did a demonstration where we measured carbon dioxide in 3 different gas streams. This was on a waste incinerator plant in Central Europe. We were measuring the gas that comes from the emission stack into the capture system. Then we were measuring an intermediate position between 2 stages of the carbon capture system, and we were measuring the gas that is released back into the stack. In this measurement, we were comparing against a reference grade non-dispersive infrared CO2 analyzer. And what we found was that the measurement in the intermediate position between 2 stages of the scrubber or the carbon capture system was very insightful, because even though the total outcome of the system is fairly stable, they could detect, for instance, that the temperature of the hot potassium carbonate solvent was not high enough, or it was not circulating fast enough when the first stage was capturing less than expected. So comparing those 3 numbers, CO2 coming in, CO2 after the first removal stage, and CO2 after the second removal stage, would highlight to the operator that they need to increase the temperature or they need to increase the recycling rate. And this ties into what I said earlier about minimizing the operating expenses. If you run the plant like that, you are not capturing as much CO2 as you could. And that's, of course, bad because you have less captured CO2 to sell to the off-taker. And if you run it too hot or with excessive recirculation rate, then you are wasting energy. So yes, you are capturing CO2, but in a too expensive way. So there is a right balance between these. And the alternate system, the system that they were using alongside our probes, was an extractive system with time sharing between three streams. So they got snapshots from those streams every half an hour or so. which is nowhere near fast enough for effective process control. So we could offer to replace a big complicated system with 3 affordable probes that give the measurements in real time. Another insight from that experiment was that we were able to do performance comparison. So even though our instrument was originally optimized for measuring that 99% CO2 stream that you get from the capture system, here we were actually measuring in the process where concentrations are smaller. 17% for the incoming CO2 from solid fuel combustion, and then intermediate levels, typically 7 and 2% for the process. And we actually got better results than the reference grade instrument, especially the repeatability was better in the test. So this helped Capsule build trust in these small in situ transmitters that you can use them to replace rack-mounted conventional solution.
So how would you say Vaisala supports measurement, reporting, and verification within the carbon capture industry? And what role do your products play in helping customers meet the existing standards?
I see basically 2 dimensions to that question. One is analyzing the product gas, verifying that it meets the pipeline spec or liquefaction spec if you are transporting captured CO2 in a pipeline or as a liquefied gas, or if you are converting it to some other chemicals like methane or methanol, then you need to meet the gas quality specification for those processes. So that's one. The other is measuring what is emitted to the air, helping the customers comply with their environmental permits. And besides just offering instruments for customers to do this, we are also participating in developing the international standards that underpin these measurements. This is still a very new emerging area, and businesses are moving forward more quickly than regulators and standards can keep up with. So Vaisala is a member of the CE and Technical Committee 474, Working Group 3, CO2 counting, and we help the industry experts develop best practices when it comes to the analysis of CO2 and the impurities in those CO2 streams.
And more to the evolving nature of the standards, which is absolutely true. The U.S. EPA is currently evaluating some of these projects and sites on a case-by-case basis. So we support, developing more universal standards in this industry. Real-time continuous data can certainly help in that effort. But the ultimate goal really is to help prevent fraud. We want to support transparency through data, because at the end of the day, if these carbon capture systems, which are trying to have a big societal impact, if one of them is found to be somewhat fraudulent, or at least data is incorrect and things like that, that one bad apple can spoil the bunch. And we want to make sure that everybody is on the up and up as much as possible, so that we can all ride this wave forward.
Absolutely. So looking forward, what future developments or innovations are Vaisala working on to further support the carbon capture industry?
These developments are to a large extent hardware-based, because we are an instrument manufacturing company. And for instance, from that case study with Capsule, we saw how important it is to measure not just that 90 to 100% bracket of captured CO2 or the atmospheric levels around 400 ppms for the GMP series, but then also the intermediate levels. And we have efforts underway to help improve measurement accuracy in all the CO2 concentration ranges of interest. So whether it is the incoming gas stream from a point source, which varies from, say, 4 volume percent CO2 for combined cycle gas turbines up all the way to 22% for a cement kiln. We are also working on improving the accuracy specifications in those intermediate volume percent ranges. We are also exploring other measurement locations, such as carbon capture systems installed on ships. Carbon capture in maritime transport is a big emerging thing, and it has its own unique requirements and challenges. Conditions can be very harsh on an ocean-going ship, but the fact that we have almost 90 years of experience with meteorological instruments, weather and environment instruments, we feel that we are up to the task when it comes to things like corrosive saltwater spray or NEMA 4X, IP66 type of ingress protection, which is not a given in most gas analyzers and scientific instruments.
Yes, and we're constantly seeking feedback from our customers for future product development for all aspects of these products, from the form factor to measurement performance, operating conditions, accessories, fitments, things like that. So we try to work as close as we can with our customers, especially in the technology development spaces, so that will help to steer our future product development.
Again, we are talking with Justin Walsh and Antti Heikkilä from Vaisala. Thank you both for joining me today. Before we close the podcast out, is there anything else you'd like to add?
If you're going to attend the 7th CCUS conference in Austria, in Vienna, Austria, in 2 weeks from now, I will be a speaker there, so it would be great to meet some of you in person.
Yeah, thank you, Danielle. It's been fun doing this, and maybe we'll do another one in the future. But for myself and, Antti as well, we're going to be exhibiting at the Carbon Capture Technology Expo in June of this year in Houston, Texas. So we'll be available there to speak with anybody, answer any questions, and show you what we're working with.
Sounds great. Well, thank you both again, and thank you to our listeners. If you or your company is interested in recording a podcast, please reach out. For more podcasts like this one, you can visit carboncapturemagazine.com and subscribe for industry news. We hope that you enjoyed this podcast and look forward to next time. Until then.